In this video, I'm going to talk through the worked out solutions for the Unit 1 review, talking about function relations. Looking at the first problem, it says identify the graph that displays the depth of water in a swimming pool after the drain is opened. Another way to think of the depth of the pool is how deep the water is or how much water is in the pool. Okay, so at the very beginning, I'm thinking if the drain isn't open, the swimming pool is full. So we should have the y-intercept for the starting point should be high because there's a lot of water in the pool at first. So I'm thinking, okay, here we start high, here we start high, here we start high. This one we don't, so I'm going to cross out D because D's y-intercept for the starting point is lower, so that's not going to work. This would be, the water would be increasing and the depth of the pool will be decreasing, I know, because if I start with that much water and then the water goes down, the depth will be decreasing. So I guess that leads me to the next thing, is which one of these show the depth decreasing? Well, this one does. This next one shows a horizontal line, which means that the dependent variable is not changing, or in this case, the depth is not changing. But we know that if you take the drain out, water will go out of the pool, so B would not work. And then C, we see that it's decreasing, but then it's increasing and then decreasing again. But if I just open the drain, I'm not going to increase the water unless for some reason I was putting, more water in the pool. So C is not correct. We'll go ahead and say A. Looking at number 2, it says during a snowy day, it snowed lightly for a while, stopped for a while, snowed heavily, and then stopped. Okay, so we got 4 things going on. It says which graph represents the total snowfall over time? So total snowfall is what we're thinking about. Well, at the very beginning when it first started, was there any snow? No. At the beginning there is no snow, so the y-intercept should be at the bottom, at the origin. And we see this one, all of them have the y-intercept at the origin, so we're good there. Then it snowed lightly. So I'm thinking, well, what's happening to the total snowfall if we're snowing lightly? Well, if the snow is falling, then this total snowfall is increasing. So we see increasing here, so that's good. Increasing, increasing, and increasing. Okay, so check there. All of them are increasing. Then it stops for a while. Well, if it stops, I'm thinking, what's happening to my snowfall? If the snowfall stops, then the total snowfall is not changing. So this is not changing, or we should see a horizontal line. So here I actually see decreasing, but this would show that the total snowfall is decreasing, which won't make sense in the problem. This one, I see a horizontal line, so snow falling, then horizontal, so that's good. Snow falling, horizontal, snow falling, horizontal. So we're good. We were able to eliminate one of the possibilities. Well, now it's snowing heavily. So I'm thinking, well, what's happening to the total snowfall if it's snowing heavily? It is still increasing, but now, excuse me, I have to compare whether it's snowing heavily or lightly. If it's snowing lightly, it's increasing at a lesser rate, versus if it's snowing heavily, it's increasing at a greater rate, so it's going to increase faster over the same amount of time. So at the first increase, we should see it being less steep. The second increase is steeper. So when I look at this, it looks like this is the only one that has less steep and then steeper, and then let's check the end of it. Then it stops again, so we see horizontal. So C is the correct answer here. For D, it says draw the graphs for the following situation. Cabrera ran from first base to second base and then stopped once he got to second. Okay, so went from first base to second and then stopped. So first, the distance from first base. Well, let's picture what's going on. If I have, what do we have in here that can help us? We'll take this Band-Aid. This represents first, okay? This represents first base. This represents second base, all right? So, in Cabrera, I'll represent with my finger. So if he ran from first base to second base, he starts at first base and he runs to second base. So in the first one, if we're graphing the time versus distance from first base, well, the distance from first base, if he starts at first base, the distance from first base is very small. In fact, it is 0. So I know if I start at first base and run to second, the distance from first base starts at 0 and then is increasing. So what I should do here, if I'm creating this graph, the distance from first base starts at 0 and then is going to increase as I get away from first base. So then he stops once he gets to second base. So if I go from first base. At first, my distance here is increasing, gets wider and wider. And then I stop at second base, which means here, now if I stop there, this distance between first base and second base isn't changing. So to show that it's not changing, I have a horizontal line. If we look at here, the distance from second base, well, if Cabrera starts at first base and he runs to second, I look at this distance, and this distance is getting smaller. So he starts far away, that is a big distance, and then that distance gets smaller when he gets to second base. So I should start far away this time, and then that distance is decreasing, getting smaller. Once I get to second base, now I've reached it, and now I can stay there. I have this horizontal line. And then finally, the speed. So let's think about speed. Well, if he's running from first to second base, he can probably run at about the same speed. So maybe he runs at a constant speed for a while. But then to stop, his speed, once he stops, means that the speed is 0. Show that the speed is 0 means this has to go down, but I can't have a vertical line because it'll take some time to stop. So then he stops, and when he stays stopped, his speed stays at 0. So this would be the graph for his speed. As you look here, this is some pre-algebra review. It's good skills to have. I'm going to go ahead and talk through this, but you won't see problems like this explicitly on the test. So if I'm solving for y, it means I get to get y by itself, everything to the other side. So that's a positive 21, which means I need to subtract 21 from both sides. Now, positive 21 minus 21, or positive 21 and negative 21 is 0. I'm left with a negative y is equal to negative 2. Got to bring down that negative. That's really like having a negative 1 there. If I have negative 1 times y, the inverse of multiplying by negative 1 would be dividing both sides by negative 1. And I get that y is equal to a positive 2. For number 5, again, I'm going to solve for x, which means I'm going to do inverse operations to get that minus 10 to the other side and that 8. And we're going to first deal with the minus 10. The inverse of subtracting 10 would be adding 10. In other words, negative 10 plus 10 is 0. So I'm left with 8x on the left-hand side and 34 on the right-hand side. I have 8 times x, so the inverse would be dividing by x. So I get x is equal to 34 over 8. If I simplify that fraction, I see that both of these are divisible by 2. So if I divide both by 2, I get that x is equal to 17 divided by 4, or 17 fourths. Now that would be the same thing as 4 and 1/4, or 4.25. All of these answers I would accept. Looking over here, again, I'm going to draw my bar. Whatever operation I do this side, I have to do this one. I'm solving for x. The first thing I'm going to do is subtract 7. Positive 7 and negative 7 add to be 0, so I have 21 is equal to 3/8 x. There's a couple different ways to do this one. I could multiply by the reciprocal on both sides, or I could say, well, if I'm dividing by 8, I could multiply both sides by 8, and that will undo the dividing by 8. So now 8 times 21, well, 8 times 20 would be 160. 8 times 1 is 1, so 8 times 1 is 8. So 160 plus 8 is 168. When I do mental math, sometimes I like to check my calculator. So if we check that, 8 times 21. All right, so we got 168, so we're good to go. Now I have to divide that by 3, divide by 3. I don't know what that is off the top of my head, but I know that if I add all these digits, 1 plus 6 is 7, plus 8 is 15. If the sum of the digits is divisible by 3, then the number is divisible by 3. So this will be divisible by 3. Let's do this one in our calculator real quick. We got 56. So 56 is equal to x. Moving on, solving for x in this equation, I got to get x by itself. I subtract 7 from both sides because positive 7 and negative 7 add to be 0. I get 30 is equal to a negative 5x. I realize that if a number is right next to x, or it's the coefficient, there's multiplication going on, so the inverse would be dividing by negative 5 on both sides. So I get a negative 6 is equal to x. Over here, I just have to solve for x. There's only one step in this one, negative 6 times x. Well, the inverse of multiplying by a negative 6 would be dividing by negative 6. Negative 6 divided by negative 6 is 1, but 1x is just x. So we'd have negative 28 over 6. And again, if I simplify, these are both divisible by 2. So it'd be negative 14 thirds. And then finally moving over here to solve for m. The inverse of subtracting 60 is adding 60, or in other words, negative 60 plus 60 is 0. So you're left with m divided by 4 equals 40. m divided by 4, well, to undo the dividing by 4, I can multiply both sides by 4, and I get m is equal to 160. All right, flipping to the back. Here I'm given that g of x is equal to 20 minus 4x, and I want to find g of negative 5. Well, when I look at that, the negative 5 is inside the parentheses, which means it is the input. And if it's the input, it means it's x. So this is really saying x is negative 5. What is the value of the function, or what is y equal? So g of negative 5 would be equal to, I just have to substitute in this negative 5 wherever I see an x. I leave that left-hand side alone, and I simplify the right-hand side using order of operations. I have to do multiplication first, so I think of this as 20. A negative 4 times a negative 5 is a positive 20, so that's 40. So my final answer will be the function g, when the input is negative 5, has an output of 40, or g of negative 5 is equal to 40. The challenge problem over here, you will not be required to do this on your quiz, or sorry, on your test, but you will be later on. So let's talk through it. It says find x when g of x equals 10. This is saying g of x, or y, equals 10. Well, if y equals 10, I'm trying to find out what is x. So if I go back to here, g of x equals 10, meaning I'm going to replace all of g of x with 10. So all of g of x will get replaced with 10. So it'll look like 10 equals 20 minus 4x. And now I need to solve for x, because the question is asking us to find x. So now I subtract 20 from both sides, because this is a positive 20 and I want them to add to be 0. I'm left with negative 10 equals, I have a negative 4x. Don't lose that negative. That negative is attached to the 4, which is attached to the x. The inverse of multiplying by negative 4 is dividing by negative 4. So when I divide by negative 4 divided by negative 4 is 1, so I'm left with 1x, or just x. Negative divided by negative is a positive, so this will really be positive 10 fourths. They're both divisible by 2, so I can say that's 5 halves. Now 5 halves is also equal to 2 1/2, or 2.5. I would accept any of those answers on a test. Scooching down, again, another challenge problem. When I tell you what h of x is, it says find x, so what does x equal? When h of x, or in case y, equals 15, which means I replace that entire thing with 15. So 15 equals 7/4 x minus 6. And now I do inverse operations to solve. The inverse of subtracting x is subtracting 6 is adding 6, or negative 6 plus 6 is 0. So I have 21 equals 7/4 x. Last time I had a fraction here, I said, well, I'll multiply by the denominator, because I'll do the inverse of dividing by the denominator. So I'd multiply both sides by 4, and then I'd have the 7 and divide by 7. I want to show you something different this time, because there is a different way to do this problem. Some students like to multiply by the reciprocal. So if I multiply both sides by 4 sevenths, the reciprocal, I can see over here that 7/4 times 4 sevenths will equal 1. The reason why is that 7 times 4 is 28, 4 times 7 is 28, so I'd have 28 over 28, which is equal to 1, and 1x is just x. Over here, to multiply these fractions, I could multiply straight across and then simplify. I like to simplify first. I know that 21 and 7 are both divisible by 7, so I'll simplify that to 3 and 1. And now 4 times 3 is 12, 1 times 1 is 1, but we'll just write our answer as x equals 12, because 12 divided by 1 is just 12. Excuse me, moving over here, find h of 16. That means that x is equal to 16. The input is 16, I want to find the output. So I substitute 16 everywhere I see an x, and when I substitute in, I need to substitute in with parentheses. Well, I'm multiplying 7/4 times 16, so 7/4 times 16. I can put 16 over 1 to help me multiply these fractions. So I need to deal with the multiplication first. Now I could simplify this first like I did over here. I could say, well, 16 and 4 are both divisible by 4, but I'm going to do it a different way just to show you you'll get the same answer. So let's say this time I want to multiply straight across. 7 times 16. Well, 7 times 10 is 70. 7 times 6 is 42. So 70 plus 42 is 112. Let's double check that math. 7 times 16, 112. There you go. So we get 112 divided by 4 times 1 is 4. I still need to simplify this 112 divided by 4. It simplifies to 28. So I get 28 minus 6, which is 22. So h of 16 is 22, or when the input of this function is 16, the output is 22. Scooching down here, so state the x and y intercepts and the domain and range, then find the function value. So our x-intercept, I know that x-intercept is whenever y is 0, so I'm going to look here and see where y is 0. Well, I don't see it. Is there a pattern here? I look like I'm adding 8, adding 2, adding 3. Okay, so there's no pattern here, so this must be just a discrete function. So I'm going to say that there's no x-intercept. There's none. Over here, the y-intercept was when x is 0. So I look here, and I see that the y, when x is 0, y is 5. So we have 0, 5 gives us the y-intercept. It's asking for f of 5. Well, that means when x equals 5, what is y? Because 5 is inside the parentheses, so does the input, or the x value. So x is 5 here. That means the output will be 6. So we have that right there. To find x when f of x is 5, that means what is x equal to when y equals 5? Well, I go to where f of x or y is 5, that's right here. So x is equal to 0 when y is 5. The domain, because we're saying this is a discrete function, we're going to use set notation. The domain are all the x values. Make sure we're writing them in order. So domain is input or x values. We want to write them in increasing order. That would be -8, 0, 2, 5, and 16, which means that the range is the output values, or in this case the f of x values or y values. To write them in increasing order, right, -80, -8, 5, 6, 35. Looking over here, we have this parabola. Now, this parabola doesn't have arrows on, but when it goes to the end of the graph, it implies that it goes on forever. So we can draw little arrows if that's helpful. The x-intercept for a graph is where the graph crosses the x-axis. So we have this point here and this point here. There are two of them. Now, they don't fall exactly where, like at interval. So we have to kind of approximate. We know that this one is between 0 and -1, and it's closer to -1. So I can approximate what that is. You don't have to have the exact answer necessarily, but I might say maybe -1.75, comma 0, something close to that. Over here we're between 2 and 3, closer to 3, so maybe I'll say this one is 2.75, comma 0. The y-intercept is where the graph crosses the y-axis, so that's this guy up here. That would be 0, 2. So again, if we want to color code these, I use pink for the y-intercept before. So the y-intercept is where it crosses the y-axis. I will use blue for the x-intercept. That's where it crosses the x-axis. F of 1 means what is, 1 is inside the parentheses, so does the input. If it's the input, it's the x value. So it means x is 1, what is y? So I go to where x is 1. X is 1 here, I go to the graph. This is the point 1, 2. That means when x is 1, y is 2, or f of 1 is equal to 2. Over here it says, find x when f of x is -1, or what is x equal when y is -1. So now I go to where the y is -1. I go over to my graph. I have this point and this point. This is the point, what does that look like? 3, -1, and this is the point -1, -1. So x could be equal to 3 or x equals -1 in this case, here and here. The domain, now this is a continuous function, which means we use inequalities to denote the domain. So let's think of the domain. Domain is the input values, which are the x values. I know that x goes left and right, so I'm going on this graph and I go to the left. I know that this graph never stops as we go to the left. It has these little arrows. So we would say from -infinity to, as I go to the right, the highest x value, well, this goes on forever, it goes to +infinity. So I could write my inequality like that, or I know that when it goes from -infinity to +infinity, we say the domain is all real numbers. So I could just write my answer like this. My range are my output values. I know output are y values, or f of x values in this case. Y goes up and down. So I'm looking at this, I want to find my lowest y value. So as I go down to find the lowest y value, I see both of these go down forever, which means the lowest y value is -infinity. And I have my y, and my highest y value go up, 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 up. Here I get to where y is 2, and then it goes back down. So the highest y value is 2. Now I actually reached 2, so I'll be less than or equal to 2. I can't reach negative infinity, so I could write the inequality like this. Some of us are looking at this and saying, though, that the highest value is 2, then it's anything below 2. So we could write it as y is less than or equal to 2 instead of the compound inequality. All right, going on to the next page. Number 14 says, Monica's driving to California. The graph below shows the amount of gas in her tank over time. Okay, so the amount of gas in her tank compared to the time. What is the x-intercept? Well, I know the x-intercept. I'll use blue again. X-intercept is where the graph crosses the x-axis. That's this guy right here. I give the answer as an ordered pair, so that'd be 14, 0. What does it represent in the context of the situation? Well, x is 14. So this is saying x is 14 when y is 0. When x is 14, that means the time is 14, and that time is an hour. So after 14 hours, 0 is the amount of gas. So we have 0 gallons of gas. Okay? So when you have 0 gallons of gas, well, what does that mean? Well, it means that your gas is empty. Your tank is empty. You have no gas left. So how we could interpret this is, after 14 hours, Monica runs out of gas. There's no gas left in her gas tank. All right, so then the y-intercept, I'll use the pink again. Y-intercept is where the graph crosses the y-axis up here. That's going to be written as an ordered pair as well. That's 0, 25, because that's when x is 0 and y is 25. What does the y-intercept represent in the situation? Well, let's think about that. That's when x is 0, y is 25. When x is 0, that means the time is 0 hours. 0 hours have passed since she started driving to California. And y is 25, so the gallons of gas. She has 25 gallons of gas in her tank after 0 hours. Well, 0 hours just means that her trip hasn't started yet, right at the beginning. So the y-intercept represents the beginning. So at the beginning of her trip, Monica starts with 25 gallons of gas. All right, looking down here, determine whether each relation is or is not a function, explain why. So we're going to have to say yes or no and explain. Well, when I look at this, I know that a relation is a function if every input has exactly one output. When I look at this input of 4, 1, or input of 4, has 2 different outputs, 4, 1 and 4, -1. That's like if I press the same pop machine button, I got Coke one time and Sprite the other way. So this is no, because the input of 4 has 2 different outputs. Over here, again, I'm trying to think through. Does each input have exactly one output? Well, this input has one output, this input has one output, this input has one output. So yes, this is a function. Now, sometimes I look at these and think, this won't be okay because they're both going to this. But this is like pressing button number 2 and getting Sprite, pressing button number 3 getting Sprite. And we talked about how you can have 2 different buttons that pop out the same soda in a pop machine. So that's okay. So why? Is it yes? Because each input has exactly one output. And we have to say exactly one, not just one, because sometimes people could say, well, it could have 1 or 2 or 3. It has exactly 1. Scooching over here, when I look at this, the input of 5 has an output of 2. I look anywhere else. Is there any other input of 5? Nope. Input of 3 has an output of 2. Is there any other input of 3? Nope. Input of 8 has an output of 2. No other input of 8 or here. Now I notice that all of these have the same output, but I don't have any input that has more than one output. So this is a function. And again, the same reason. Each input has exactly one output. It is okay to have all of these different buttons pop out like water every single time. I press button number 5, get water. Button number 3, get water. Button number 8, get water. Button number 9, get water. That's okay. It is a function. Scooching down here, create a graph that is not a function and explain why is it not a function. Well, I know it's not going to be a function if it doesn't pass the vertical line test. So if I draw something like this graph does not pass the vertical line test because it a vertical line intersects this graph in more than one point. So this would be an example of a graph that's not a function. Why is it not a function? The graph doesn't pass the vertical line test. There's a lot of different options here. We just have to make sure that I can draw a vertical line that doesn't cross through, or that crosses through more than one point. Now I want to create a graph that is a function. Well, as long as there's not a vertical line that hits more than one point, we're good to go. So I could be increasing, decreasing all I want, but as long as there's no vertical line that hits more than one point, I'm good to go. So why is this graph a function? Because the graph passes the vertical line test. All right, moving down to number 19. Refer to the graph to the right, determine the domain and range. We see a parabola again. Because the graph goes to the end, assume that these arrows go on forever. The domain are the input values, which means that they are the x values. X goes left and right. So I want the lowest x value, so I go to the left, and because that arrow goes on forever, the graph never stops going to the left. The graph will never stop going to the right. So the domain goes from negative infinity to infinity, or it's all real numbers. The range are the output values, which means they're the y values. I know the y-axis goes up and down. So if I want the lowest y value, I start going down on this graph, and this is the point 1, 3, which means the lowest y value is 3. The highest y value, well, when we go up, it goes on forever, which means the highest y value is infinity. It never reaches infinity, so I just have less than. It does reach 3, so I have less than or equal to. Another way to say this is just that y could be 3 or anything above 3. So you could also write this as y is greater than or equal to 3. Switching down here, find f of 1. That means 1 is in the parentheses, so it is the input, or the x value. So it says x is 1. What is y? Well, I go here to where x is 1. I go up to the graph. This is a point 1, 3. There's only one point where x is 1. So f of 1 would equal 3. Find x means what is x when f of x equals 5, or when the output is 5, or when y equals 5. So I go to my graph where the output is 5, that's right here. Now if I go over though, there's 2 points here. So we have the point 2, 5 and the point 0, 5. So x would equal both 0 and 2. There are 2 different points where the output is 5. The x-intercept is where the graph crosses the x-axis. This parabola never crosses the x-axis, so there are no x-intercepts. The y-intercept is where the graph crosses the y-axis, so this point right here would be the y-intercept, or 0, 5. And we got to make sure we write that as an ordered pair. Remember that it is a point. All right, and finally down here, the last one, it says create a linear graph. So we know the graph has to be a line with an x-intercept of negative 2, 0 and a function value of 3, 5. Okay, well, negative 2, 0, we know that point is right there. To have the function value 3, 5, that means the input, or the x, is 3, and the output is 5, or y is 5. So I go to plot the point 3, 1, 2, 3, 4, 5. I have that point there, and it wants a linear function, which means the graph has to be a line, so I can connect these 2 points with a line. And that would be the linear function with an x-intercept of negative 2, 0, and the function value f of 3 equals 5. So flip to the back, we just have our answers, so please check your answers to the rest of these on here as you work through it, and good luck.